Welcome everyone. Today we're going to be looking at reviewing what we know about slope from our Algebra 1A and Algebra 1B classes. So our slope is going to be describing the steepness of a line. When we're talking about slope, we will be using the variable m to represent it. So we can find slope a couple of different ways. When we're using a coordinate plane, so we have a line that's drawn on a graph, we're going to be looking at slope using the description rise over run. Or we often think about this as the vertical change over our horizontal change. When we don't have a graph, but we are given 2 points that are on the line, we can still find slope. And we're still going to use this vertical change divided by horizontal change, except we're going to be using some actual values this time. So we're going to be taking our first y value minus our second y value to give us that vertical change. We're going to divide it by our first x value minus our second x value to get that horizontal change. And we're going to go ahead and see this in action in just a minute here. So we have 2 special types of slopes, and I will refer you to the Slope Dude video if you want a fun way to remember these guys. So our first special slope is going to be this 0 slope. So what do we know about that? Well, when we have a slope of 0, that's going to mean that if we're thinking about our rise over our run, and we want this to be 0, that means we want our numerator to be 0. So that means I have no vertical change, but I still have my run or my horizontal change. So this is going to simply look like a horizontal line. So what does a line look like when we have an undefined slope? So anytime we're thinking about a fraction and we're thinking about plugging that in the calculator, we want to think about, for an undefined slope, what gives us an error. And that always happens when we have a value of 0 in our denominator. So that means we have a rise, but no run. So we have all vertical change, but no horizontal. So this turns out to be a vertical line. Okay, so those are just 2 special slopes that we want to keep in mind as we're going through. So we're going to take a look here at some examples of using either our rise over run analogy or that y1 minus y2 divided by x1 minus x2. So when we're finding slope on a line, like example number 1 here, we want to be taking a look at reading our graph just like we would read words from left to right. So you want to go ahead and select your leftmost point, and then you want to connect it to the next point by rising. So doing a vertical movement, and sometimes it'll be up, sometimes it'll be down, and then running. So because we're going from left to right, your run or your horizontal movement will always be to the right. So we're going to rise and then we're going to run. So in this case, we rose 3 units. We ran 2 units. When we rose, we went up. That's a positive value. When we ran, we went to the right. That's also a positive value. So now we need to write this as slope. So our slope is our rise divided by our run. So we would have 3 over 2. All right, let's take a look at it for the second one. So we're still going to start at our leftmost point here. This time, when we're going from left to right, we have to go down because we always want to do our vertical movement first. So we're going to go down, and then right. Okay. When we moved down, we went down 2 spaces, and down is always a negative movement. And then when we went right, we went right 1, 2, 3, 4, 5, it looks like 6 spaces there. And that's to the right, which is positive. If you go to the left, that's the negative horizontal movement. We want to write this now as a fraction, rise over run. So that would be -2/6. And anytime you're looking at a fraction and the number in the numerator and the number in the denominator have a common factor, you always want to reduce. So both -2 and 6 are divisible by 2. So we want to reduce this to a -1/3. Okay. So we can still find slope even if we're given just 2 points on a line. So this is where our formula for slope comes into play, that y1 minus y2 divided by x1 minus x2. So if we're looking at our points here, my first point, I'm going to label them as my x1 and my y1 values. My second point is going to be my x2 and my y2 values, and I simply need to plug those into my formula. So do pay attention to the order in which you're going. So if I go 4 minus 14 for my y values there, when I look at my x, I have to do -2 minus 2. My suggestion would be in your calculator or whatever application you're using as a calculator right now, try to type this in all as one fraction, or we can simplify it by hand. So 4 minus 14 is a -10. -2 minus 2 is a -4, and we always want to check and see if we can reduce our fraction, which we can. And here it would be 5/2. All right, doing another one. So again, we want to label our first point x1, y1, and our second point x2, y2, and then plug them into our formula. So we would have -9 minus -7. So be very careful here. You have to have both of those, both the subtraction and the negative on the 7. Don't lose one of them. We're going to divide that by 5 minus 11. And we're going to go ahead and simplify. So -9 minus -11 will come out to be a +2. A -2. 5 minus 11 will come out to be a -6. And then we want to reduce to 1/3.